Hello, my name is Madeline Davis, and our project is using morphometry to analyze the effects of e-cigarette smoke exposure in the lungs of musculus. I did this project under the supervision of my mentor, Dr. Gabriele Grunig, at the Environmental Lung Disease Laboratory with NYU Langone. First of all, I'm going to start off with a quick introduction into e-cigarettes. So e-cigarettes are handheld vaporing devices that simulate smoking. They do this by creating an aerosol for the user to inhale and by heating a solution containing nicotine, glycerol, propylene glycerol, flavorings, and additives. Flavorings that are commonly used and that we'll be looking further into this study include vanilla, cinnamon, and limogen. In the image on the right, you can see some common e-cigarettes. Due to the known dangers of smoking traditional cigarettes, which has been associated with illnesses such as COPD and asthma, many longtime smokers are switching to e-cigarettes. What's even more concerning, however, is that millions of adolescents are starting to use e-cigarettes without ever using cigarettes before. This just creates a whole new generation that is addicted to nicotine. And it has not yet been proven if e-cigarettes are a safe alternative to smoking. So this past summer and fall, thousands of people had been hospitalized from mysterious illnesses relating to vaping. These cases gained rapid media attention in August 2019, and they peaked in September 2019. These illnesses were called EVALI, which is short for e-cigarette and vaping-associated lung injury. According to the CDC, almost 3,000 cases have been reported in all 50 states across the US, and 68 people had died. Now, some new research has found that these illnesses may have been related to some THC components in some e-cigarettes. However, the CDC stresses that it's not yet known what specific components of e-cigarettes cause EVALI. So a part of the immune system that we'll be looking into in this study are lymphocytes, which are white blood cells. The two primary types of them are B and T cells. They're both lymphocytes, but they both have slightly different roles. So B cells produce antigens to protect the body. B cells produce antibodies to protect the body against antigens, which are foreign substances, and T cells control the immune response to foreign substances. In the lungs of mice, lymphocytes tend to congregate around the blood vessels, especially near airways. So lymphocytes are a good indicator of general health and health of the immune system, as high levels of lymphocytes is a sign of inflammation, and low levels can occur when the body is under severe stress. Preliminary studies have demonstrated that there are some dangerous effects on lymphocytes due to smoke inhalation. So the hypothesis of the study, which is what we had thought would happen before it started, was that e-cigarette exposure causes alterations in the blood vessels in the lungs of mice, specifically a reduction in lymphocyte count and increase in the thickness of the blood vessel walls. So the first part of the methods is the exposure period. This is the part of the study that my mentor had completed. 57 mice for two different studies were exposed. The first study, to compare flavorants, mice were exposed for 4 months in 4 groups: room air, the control, vanilla, limogen, and cinnamon. There were 7 mice per group. To compare specific components, mice were exposed for 3 months. This also had 4 groups: air, eugenol, nicotine, propylene glycol, and vegetable glycerin, with 7 to 8 mice per group. As you can see on the right, these are some examples of the containers in which the mice were exposed to the e-cigarettes, the e-cigarette aerosol. So the second part of the methods is the measurement and analysis period. This part of the study I completed under supervision from my mentor. I measured the number of lymphocytes per blood vessel and also the blood vessel wall thickness. I took the median for each slide, so for each mouse, and I divided them into groups of size less than 50 micrometers, between 50 and 100 micrometers, and greater than 100 micrometers of the blood vessel, as well as a total. I analyzed the data using Prism and completed a power recalc using G-star power. I would like to note that I was blinded during this study. On the left, you can see an example of a slide that I looked at. You could, on the very left, under where it says lungs and spleen, you can see numbers. That's all I knew about for each slide. I did not know which numbers had corresponded to which group or even which study until I analyzed them. And now we have the results. First of all, the results for comparing flavorants. We found a significant decrease in the number of lymphocytes surrounding blood vessels in the lungs of mice exposed to vanilla as compared to room air. This is proven with a Welch's t-test, an unpaired t-test, and a Mann-Whitney test, using a p-value of less than 0.05. As you can see, this is an example of a slide that we looked at in which this mouse was exposed to room air. Around here, as if you can see my pointer, in the circle we looked at the number of lymphocytes, which you can identify by the small purple dots. So as you can see, there are a lot of them in these two blood vessels with room air. However, in vanilla, the second one, you can see there's a lot less. We found this trend throughout almost all of the lungs. And also, we conducted a power recalc of samples of group sizes of 24 for 0.05 error probability for room air to cinnamon, as we had noticed a trend in the decrease, especially with larger blood vessels. However, this is not proven statistically significant. We also found that vanilla had caused a decrease in blood vessel wall thickness. In the second study, we had compared components. We found a trend of the decreasing number of lymphocytes in eugenol as compared to nicotine, especially for blood vessels that were greater than 100 micrometers. To clarify, the solution labeled eugenol had both nicotine and eugenol, while the nicotine solution did not contain eugenol. So essentially, the nicotine solution is the control for the eugenol. And this trend was proven significant using a Welch's t-test and an unpaired t-test. However, I will note that a Mann-Whitney test found that this trend was not significant. So, to conclude, this research suggests that e-cigarette ingredients could have varying levels of toxicity. Vanilla, as shown of a significant decrease in lymphocytes and also a decrease in blood vessel wall thickness, is likely more toxic than other flavorants. In addition, e-cigarettes with eugenol could possibly be more toxic than those with just nicotine or propylene glycol vegetable glycerin component. Future research is needed, however, to clarify the findings of this study. Some plans in the future include immunizing the lymphocytes to differentiate between B and T cells to determine exactly which cells are being affected and exactly what part of the immune response is being damaged. In addition, a repeated experiment with larger group sizes and longer exposure periods is needed to clarify the findings. Here are some of my references. So, to note again, my name is Madeline Davis, and you listen to my presentation using morphometry to analyze the effects of e-cigarette smoke exposure in the lungs of musculus. Thank you for listening.